What is love? Baby, don't hurt me. Don't hurt me no more.
Hello everyone, welcome to this calculus tutorial. Since we're done at the derivatives of non-trigonometric functions, today we will explore two fundamental concepts, the derivatives of trigonometric functions and the antidifferentiation or integration of non-trigonometric functions. Differentiation helps us understand how functions change, while integration helps us determine the accumulation of values over an interval. Mastering these concepts is essential in physics, engineering, economics, and other fields. Let's begin with the derivatives of trigonometric functions. Derivatives of trigonometric functions. Trigonometric functions, such as sine, cosine, and tangent, have well-defined derivatives. These derivatives are widely used in motion analysis, oscillations, and wave functions. There are 6 basic trigonometric functions, and their derivatives follow specific rules. We will now explore their fundamental differentiation formulas and apply them to practical problems. Once we understand how to differentiate these functions, we can analyze their rates of change and apply them to real-world problems. Real-life application of derivatives of trigonometric functions. Number 1. Physics. Describing wave motion, oscillations, and forces. Derivatives of sine and cosine functions helps describe wave motion such as sound waves, light waves, and ocean waves. Example: the acceleration of an oscillating object, like a pendulum or spring, is a second derivative of its position function. Number 2. Engineering. Signal processing, electrical circuits, and mechanics. In electronics, trigonometrics derivatives are used in AC circuit analysis and modulation of signals. Example: the rate of change of voltage and current in an alternating current or AC circuit follows sine and cosine functions. These are just few ways derivatives of trigonometric functions help us understand the world around us.
So here we have the 6 derivatives of the basic trigonometric functions. So let's start with the first one. So the first one is the sine x is equals to cosine x. Next is cosine x is equals to negative sine x. Next is tangent x is equals to secant squared x. Next is cotangent x is equals to negative cosecant squared x. Next is secant x equals to secant x tan x. Next is cosecant x is equals to negative cosecant x cotangent x. So we have one example here. The given is 3 sine x minus 5 cosine x. So hanapin muna natin yung derivatives nila. So ang derivative ng sine x is equals to cosine x. Ang cosine x naman ay negative sine x. So ngayon, ilalagay lang natin siya dito, parang ililipat lang natin yung derivatives nila. So palitan na natin. Yung sine x, gagawin natin cosine x. Minus kung ano yung derivative ng cosine x, which is negative sine x. So yan. So meron tayong dalawang negative dito, pansin nyo. Ngayon, pagta-times na natin to para siya maging positive. So ang magiging final natin sagot ay, wait lang, hindi lang nadugtungan. Sorry. Ito. Yan. So, f of x is equals to 3 cosine x plus 5 sine x. Ano na siya? Positive na siya, hindi na siya negative since pinag-times natin siya.
Number 2. Antidifferentiation or integration of non-trigonometric functions. Now that we've covered derivatives, let's move on to antidifferentiation, also known as integration. Integration is a reverse process of differentiation. Instead of finding the rate of change, we determine the original function from its derivatives. In this section, we will focus on the integration of non-trigonometric functions, such as polynomials, exponential functions, and logarithmic functions. Understanding integration allows us to compute areas, solve accumulation problems, and model continuous growth or decay. We will now explore the fundamentals integration rules and apply them to various functions. But first, what is antidifferentiation? Antidifferentiation is a reverse process of differentiation. It helps us find a function whose derivative is given. We call this function the indefinite integral, written as f of x dA. This symbol, the slant, represents integration, and dx tells us that we are integrating with respect to x. When we integrate, we always add c, the constant of integration, because differentiation removes constant. Real-life application of antidifferentiation or integration. In physics, finding displacement from velocity. If we know the velocity function of a moving object, integrating it gives the total displacement. For example, a car's velocity function can be integrated to find the total distance traveled over time. Number 2. In economics, calculating total revenue and growth. Integration helps economists calculate the total revenue from a marginal revenue function or predict economic growth. For example, the total profit a company earns over time can be found by integrating the revenue function. These applications show how integral calculus is essential in solving real-world problems.
So, meron po tayong given dito ng anti-differentiation po. Yung unang given is 4x cubed minus 2x plus 7. So, isa-isa natin siya integrate. So, kapag in-integrate mo po itong 4x cubed, magiging 4x raised to 4 over 4. Bakit po? Kasi ito po, parang nagpa-plus 1 lang po tayo lagi dito. Plus 1 po. So, parang 1 plus 3 po ganun. So, magiging 4x raised to 4 po siya. And, ang mangyayari po, bababa lang rin po natin to. Parang copy lang po. Ika-copy lang. So, since 4 naman po to and 4 na rin to, 1 na rin yun. So, ang magiging final nating sagot dyan is x raised to 4. May 1 dyan, pero pwede rin naman hindi ilagay. Ang sunod nating i-integrate is, hindi na natin i-integrate yung 2 since kapag tinaas mo naman yan is raised to 2 lang naman. So, pag i-integrate mo po itong negative 2, magiging negative x raised to 2 po siya. So, move na tayo dito sa 7. So, ano po siya, respect to x po, ang magiging sagot lang po is 7x. And yun lang po, baba lang po natin siya. So, unahin natin itong sagot natin dito. Ibababa natin itong x raised to 4. Ito. Tapos ito naman, di ba sabi ko, i-integrate natin to. So, magiging raised to 2 na siya. So, negative x raised to 2. Plus 7x plus c. Bakit may plus c? Dito po kasi sa anti-differentiation, lagi po tayo nagpa-plus c, which is yung constant po. Okay pa. So, meron po tayong another given po dito. Ito po number 2. So, yung given naman po natin dito is e raised to x. Yan lang po. E raised to x. So, tulad po ng ginawa natin dito kay number 2 po. Diba, tinaas lang po natin siya. Pero which is wala naman na po number to. So, parang ikakopy na lang po natin siya. Ayan o. Ex, baba na lang po natin. So, f of x is equals to ex, e raised to x plus c. Lagi po may plus c. Ayan lang po. Ganun lang po siya. Ito po yung pangatlo nating given, which is 3x squared plus 5e raised to x minus 4 over x. Integrate po natin ulit sila isa-isa. Ngayon, unahin po natin itong 3x squared. Ngayon, integrate po. 1 plus 2, 3, tapos baba lang po. So, yan na po yung naka-integrate na 3x squared. Sunod naman po is 5e raised to x. Raised to x po to raised to x. Yun pa rin po, constant pa rin po siya, ganun pa rin po, wala nagbago. Since katulad na rin po nandito, tsaka nandito, ito po. Ngayon, ito naman pong, yung pangatlo po nating i-integrate. Since x na lang po yung nasa baba, hindi na po natin isasama. So, ang magiging integrate, pag in-integrate po natin siya, magiging negative 4 na lang po. Ayun na lang po yung matitira. So, then, lagay na po natin. Since 3/3 naman to, magiging 1 lang rin, pwede nating hindi ilagay. So, ang ilalagay na lang natin is x cube. X cube plus 5e raised to x minus 4 plus c. Huwag kakalimutan ang plus c. So, yun lang po ang tatlo nating given sa anti-differentiation po.
These applications show how integral calculus is essential in solving real-world problems. To summarize, we learned how to differentiate trigonometric functions and how to integrate non-trigonometric functions. Differentiation helps.